this project is funded by the Department of Water and Environmental Regulation, with co-contribution from DPERS, who I work for. So I work within the soil science and crop nutrition portfolio, and it's a really great portfolio to work for in DPERS. We have a great range of really experienced scientists, and then a lot of us younger scientists, and we work on really quite collaborative projects a lot of the time. And down the bottom, I've got two photos of just a couple of weeks ago putting in a re-engineering trial down in a heavy sodic grey clay in Tilbrunna near Tambler. And I'll do a quick plug for Jouse, who's got a job at the moment in this re-engineering project, which is really, really exciting. So this project is being done by Chris and I. So essentially, we've got a soil testing company going out and doing the soil testing work, and then I'm collating it all together and asking Chris about 50 questions a day, and he's providing great direction. So it's really nice. So what's the aim of on-farm soil acidity and nutrient management? Essentially, our project aim is to reduce nutrient leaching to waterways from wheat belt farms, and we want to do this by improving the nutrient use efficiency through soil acidity amelioration and applying fertiliser to meet agronomic need, as well as improve crop drought resilience by improving the crop health and rooting depth. So, most of you be aware, as we reduce our pH to below 5.5, we lose a lot of the availability reduces of key nutrients such as nitrogen, potassium, phosphorus, and trace elements such as aluminium increase. And once you get to a certain level of aluminium, it becomes toxic to plant roots and it stops cell elongation. So I guess it's really important for us to think about we want to put fertiliser on paddocks when it's this expensive right now. It needs to be utilised really well, and we need to utilise it in a way that prevents it from going into our waterways and looks after our ecosystems where our farms are located. And then also, importantly, we've got variable climate and variable rainfall, and we see a lot of dry springs. If there's a toxic aluminium layer, those roots can't penetrate down through that toxic layer, and generally there might be subsoil moisture down there, but if there's a toxic layer, those roots can't access that moisture. So we see hang on crops, so very important in our system. And having a good pH is also important for soil microbial activity. So this project started in 2020 and it'll go through to 2023. Between 2005 and 2012, Chris and his team did a big body of work soil testing out in the wheat belt. And from that work, they were able to write the soil acidity report card. And that's been really useful as a tool for me to now be able to benchmark where we're at with some of our soil results. So it's about 10 years between when Chris wrote this, or collated all that those results and wrote this, and to now. So it's a really good time period to go and see how we're tracking against where we were. Some of the key messages from the soil acidity report card were that they found that 70% of topsoil, so the 0 to 10 centimetre layer, were more acidic than recommended. So they had a pH of less than 5.5. 50% of subsoil, so they were measuring the 10 to 20 centimetre and 20 to 30 centimetre layer, were more acidic than recommended with a pH of less than 4.8 in calcium chloride solution. So the opportunity cost was estimated at almost $500 million annually due to soil acidity. They also did a whole bunch of Time to Lime articles from the Farm Weekly, so it's been really cool being able to go through a few of those. and just see how extension was done in 2007 and 2008.
I am Christian.
Yeah. So they've also produced that some really good graphics where we had those soil acidity issues. So you can see on the left, that shows the percent of samples that were below a pH of 5.5, with the dark red being 75 to 100%. And then on the right, we have the percent of samples below a pH of 5. So 5 being kind of that critical level and 5.5 being a target. And it just shows that there was lots of scope for improvement. As we go down the profile, you can see the percent of samples that were below the target and below the critical, and it starts to really highlight those deep sands around Merredin, as well as some of the duplex soils in the Lakes districts. And 20 to 30 looks quite similar to the 10 to 20, again, highlighting the deep sands and that duplex layer. For this project, we were just looking at the Avon River basins, so not the coastal sands and not the Great Southern or the Albany Port Zone, so more of that central wheat belt area. So between 2020 and 2021, so the summer, we did about 30 farms were tested. The bigger the dot, the more sample sites per farming business. And then between 2021 and 2022, about another 100 farms were tested. So it's given a really nice spread of results across that Avon River basin. So the grey bars indicate the samples taken in the 2020-2021 season, and the blue indicates the summer just gone. So you can see that there was almost 2,000 samples taken in 2021 and over 5,000 taken in summer just gone. So what that means is we've got about 7,000 individual sample sites that we're getting this data from, and a fair number of growers, they didn't just sample the 0 to 10 layer, they went down and sampled 10 to 20 and 20 to 30, and even some were sampled down to 50. So it means we've got a good understanding of the soil profile and the acidity to depth. And the total number of samples is sitting currently around 22,000. So this is a good graphic, I think, because it's kind of, they've made some, given you a fork in the road back in 2008 and said where you could get to by 2020, and we're 2022 now. So essentially, this Time to Learn article was saying, if you, in the Avon River Basin, so the exact working area we're looking at, if you test to depth and apply lime as required and then continue to monitor, 80% of this region should meet target pH, and that will lead to increased profits and sustainable production. Whereas if you do not look at liming as a serious thing and you apply insufficient lime, 85% could be below target, which would lead to lost production, restricted rotation choices, and increased off-site effects. So I thought it was really interesting to just kind of have that before we went through the results. So I've separated all the results by depth and then kind of got 100% of the results and then broken into the percent that's above target, below target but above the critical, and then below the critical. So for the 0 to 10 centimetres from those 7,000 sample sites, we found that 54% were above the target pH of 5.5, 28% were between that 5 to 5.5, and 18% were below 5. And so we've got about 46% of the samples that were below that target. Go down, you can see the target becomes 4.8, and 73% of samples were above that target between the 10 to 20 centimetre layer. 15% were between 4.5 and 4.8, and 12% below critical. And then deeper again, and 78%. So it's slightly increased a little bit between those two. As we go deeper, we see that the below critical, there were 15% of the samples, but again, it's really important to recognise that we had a smaller sample size here. And then deeper down, 85% were above that target. So I think it's a really encouraging study, given that there has been 10 years and everyone accepts we need to lime, but they're actually doing it. So some of the key findings so far, just comparing to our benchmark study. So in the 2005 to 2012 results, like I said before, the 0 to 10 centimetres we're finding 70% of the samples were below that target pH 5.5, whereas now we were finding 46% were below 5.5. And in the subsoil, 50% of samples were below the target, whereas now we found so far that 27% were below 4.8 in the 10 to 20, and 22% below 4.8 in the 20 to 30. So it's showing progress, and we've had some really good production years in the last 10 years. And so liming is required to sustain the pH, but what we're seeing is improvements in pH. So yeah, it's very encouraging. So I've taken some screenshots of some of the farms that we've sampled in this project. So just using that traffic light system again, green being meeting target, so good, orange being between target and critical, and red being below the critical. Just to highlight kind of some of the little issues we're starting to see possibly arising. So I think these are very different locations in the wheat belt. So we can see that the growers are actively liming, or because the topsoil pHs are above the target. But then as we go down, you can see that we're seeing some issues at the 10 to 20 and the 20 to 30, and that goes along with some anecdotal evidence as well. So we're working with an agronomist closely, and he's been collating his soil test results from the same locations with his growers, and saying we're seeing that issue between 10 to 30. Growers are actively liming, but it's not getting down.
Sorry, Alice, just to be clear, is it that the central circle is the 0 to 10 as a colour, and then the next outer one is 10 to 20, and then the
one is 20? That's a good point. This is how I do it all the time, but I need to explain it a little bit better. The smallest circle is 0 to 10. The next largest is 10 to 20, and the biggest circle down the bottom is 20 to 30. So you can see from these samples that a lot of the topsoil, or all the topsoil, was green, and then it looks like the pH decreases down the profile. So working with that agronomist, it's been really good because he's given me a lot of results from the early, or like 2013, 2014. And so we've been able to model, okay, so your growers are applying lime, and why are we having these issues, kind of thing. So using iLime, which is a great app, you can download it from the App Store on Apple products. So you input your rainfall, soil type, crop rotation, and you can give 2 different liming scenarios, and then you can calculate how different one scenario is to the other in terms of pH, yield, and profit. So this is one of his case study growers, located in the central wheat belt. They receive a rainfall on average of between 325 to 450 mils, and they're a sand over sandy loam. So it's not an average of multiple soil results. It's just one location on one farm, but it is quite representative of that grower's farm. So the topsoil has a pH of 4.8. I'll just try and make that clearer with my mouse there. And then as we go down, it drops a bit to 4.6, and then it rebounds a little down at that 20 to 30 to 5.1. The crop rotation that this grower uses is lupin, wheat, wheat, canola, wheat. So he's a continuous crop. So the two different scenarios I've put in here, they're using the same source of lime, so both having the generic West Coast lime sand. The blue line represents the grower going out and spreading 2 tons every 10 years, just using a spreader. And then the red brown line is 4 tons in year 1. So the same amount of lime, just 2 different kinds of applications. And as you can see, the 4 tons obviously will be a bigger financial hit in the first year. And then as we get to year 10, we'll start to see those 2 lines, the space between them narrows. So I guess just to start out, the aqua line shows if you weren't to do anything, so unlimed, and the pH starting at 4.8, after about 20 years is down to almost 4.2. And the 2 tons in every 10 years moves the pH from about 4.8 up to 5.5, and then again up to about 5.7 after 10 years. 4 tons, obviously much higher concentration, we see the pH go up to about 5.7, and then slowly taper off. As we go down the profile, starting at 4.6, unlimed, we're getting down to about 4.2. The interesting thing here is to start seeing that applying 2 tons every 10 years doesn't seem to gain you anything. It just sustains that until we get to about year 15 or 16. So it's a long time to see any change. And then the 4 tons in year 1, it slowly gets down there, and about year 6 where you start to get up to about 5. And then we look at 20 to 30 centimetres, and essentially it doesn't seem to have any impact, that surface applied lime. So it's really interesting to see that 20 to 30 centimetre layer. If this is what he recorded in 2014, then we can kind of think that, 10 years later, we're probably going to be below 5 and going on a downward trajectory. So you can also look at the model with incorporation. And so what I've done is just compare the scenario we had before, and then taken away that 2 tons every 10 years and done 4 tons with incorporation to 20 centimetres. So as you can see, on the left is just the same scenario we were looking at before, and then on the right, the blue line is 4 tons incorporated to 20 centimetres. And you can see we don't get the pH quite as high, obviously, because the lime has been mixed through the profile, so it's a diluted amount, whereas before we had 4 tons just sitting on the surface. And then as we go down to that 10 to 20 centimetre layer, we can see a real change, and the incorporation has just placed that lime in that layer, and it's starting to have effect straight away. And then down at the 20 to 30 centimetre layer is also really interesting, as we can see the lime is having effect down there, whereas previously it wasn't. So I guess having a model, obviously nothing's ever going to be perfect, but it's been really nice to work with this agronomist and to look at his results and to see that scenario play out in the model. So key messages so far from this project is that we are seeing improvements in soil pH compared to 2005 to 12. But I think it's also really interesting to say, to see that the surface applied lime is having an effect, but we might be needing to start thinking about those 10 to 20 and 20 to 30 centimetre layers, which growers are. They're definitely thinking about it, but with liming being such a big investment, we don't want to just do it because we know we should be doing it. We want to do it with an approach that's going to get you return. So I guess it goes hand in hand with how the department now, in all our work, we're not looking at one soil constraint really in isolation. We're always looking at multiple constraints. And if you're going to do strategic tillage, it's about managing possibly non-wetting compaction and making sure we put some lime there to incorporate that as well. So where to from here? So we've been working with growers. So the growers work with the soil testing company and they get their results straight away and they get a lime recommendation straight away. But we're going to do workshops and little field things this year just to kind of get that conversation about what we're finding and the best way to get return on investment for that lime. And we still have one last season of soil sampling. So hopefully we'll fill in just a few more of those gaps across the Avon River Basin. Cool, thank you. Yeah, any questions?
I'm just going to sit near the speakers so that I can. So people who are online, you're welcome to send questions through by the chat. If you can hear me ask the questions, then that's great. If you can't, then I'll get Alice to repeat them, but you should be good. Shall I start off with the audience here? Does anyone have a question for Alice they'd like to ask?
Yeah, just a quick one. So alongside the sampling data that you're collecting, are you getting an idea of what liming strategies the growers might have taken in those areas as well, or is it just the...
No, and that's why we've gone and kind of worked specifically with an agronomist, just because we're doing the soil sampling through precision soil check, because it means that we know that the samples are being done to a certain standard, but it's kind of a one-off scenario. So we've worked with this agronomist because he's very much based in the Avon River Basin and he's seeing this issue. And, you know, liming has been done a lot, but it's such a big issue and, yeah, such a big investment for the business. So he's given us a huge help in providing his data set of a few farms, and then we can make actual case studies that are kind of generating what we're seeing in some of those soil sample results.
So you're going like target, or she kind of got that big data?
Yeah, so yeah, looking at different kind of scenarios, and I guess it's really cool because he's worked with these guys for 5 years, 10 years, and he can tell me exactly his scenarios, and then we can import them and tease it and compare and discuss.
Great, thank you.
I'm going to go with me with a follow-up. So just because I was thinking about that, because in your resampling, you've shown an improvement in the number of sites or the percentage of sites that met targets at the surface, but also 10 to 20 and 20 to 30, which to me, given your other data, suggests that they have to have been doing some level of intervention to get it mixed down deeper. So I guess it's just it would be a great asset to be able to spend some time getting that history of management around those sites. Certainly encourage it.
Yeah, and that's I think really now having all this data, it's like, oh, okay, I've never really had a big data set to work with before.
Yeah.
But yeah, you start to miss out those little things, and I think the case study, although it's only one farm, the learnings around and why they did that, it's so important, because you can have a huge data set that tells you something, but yeah, you need to know how they did it, where they're going to really be able to share that. So yeah.
So I'll come back to the audience in a minute, but I've got one from online. So what control have you had over the quality of lime used in these trials? We've found significant variation from different providers.
Yeah, so we don't know essentially what people have been doing. And, you know, I worked in Esperance for a long time and it wasn't great. quality. That you can see that on iLime, because you can go into the different lime options and see what quality, and then obviously cost of freight to get.
Yeah.
You don't get red gate lime and take it all the way to Esperance. It's so expensive. So, you know, we don't know what they've been doing. And with all the on-farm lime sources, we don't know either.
But the app would be useful for them to, you know, contemplate perhaps how that influenced it. Yeah.
Yeah. So, yeah, no, the app is a huge resource, and that gets updated annually with the lime quality results.
Okay. So that's updated with the industry results. Yeah. Great. Yep.
I have a couple of questions. So the app, like you're mentioning, where the lime came from, do people put in that information and it gets recorded into the data set as well?
So annually we go and take some samples from the lime pits and they get tested, and then the options on iLime get updated.
And then they can choose.
And then they just choose, yeah. So when there's generic West Coast lime sand, it's a choice. I haven't created it.
And another thing is, when you put the lime on the fields, can there be any detrimental effect, like if it washes off? Or...
Chris, that might be a good one for you. Go
I
ahead.
mean, I guess if it's just spread on the paddock and then there is an erosion event, then it's at risk of being lost. But no more so than it's not the dust bit that you see, the particle sizes, and if you've got good stubble on the ground, then not really. We don't see a big movement unless you see a mass movement of soil, which can actually bring a lot more other problems with it. So I just made a comment about that iLime app. It has it's both Google and Apple, so you can put in those different, do the what if scenarios for the responses that you're looking at.
Great. I'll just do another online one. So, is the application of lime the only way farmers can increase soil pH?
Well, we're seeing a lot of on-farm lime, I guess. We're calling it on-farm, just kind of higher pH soils that are being spread on to the lower pH soils. I'm trying to think of other strategies that I've seen there besides that. I don't think I've seen really any.
To treat the level of acidity that we're looking at and to manage it, it's created from the farming practices, which is removal of produce and loss of leaching of nitrates. Really, any carbonates are what will do it. So lime, the on-farm lime is the carbonate deposits in the eastern wheat belt mainly, or dolomites.
Yeah, but I guess what would be important there would be to consider things such as neutralising value, you know, how far you need to bring it onto site, all of those sorts of things. So yes, it sounds like there are other strategies, but in this case, you focus the project on lime application.
I guess in a way we haven't really done anything so much on lime. We've just done a lot of soil testing.
Okay.
So we're just using our understanding that growers know that they should be liming, have been doing it themselves, and we're going out and checking that their pHs are responding to good practice.
Okay. Have I got any? I've got some more, Steve.
Not a question, but a comment, really. You're saying that farmers are doing this. The farmers that you've got data for are doing this, but that's a small percentage of the total. Precision soil tech samples, you know, less than 10% of farmers in the state. So the data that you've got is quite a select subset, and I've looked at it of people that we sample, i.e. the data that you have, compared to farmers that sample themselves or farmers that sample fertiliser companies in a different way, probably more focused on the surface soil than to depth. And there's clear distinctions that the proportions that you're seeing are the upper end of what's going on compared to the general population. So yeah. I think you just have to be a little wary about saying, you know, it's all good and it's all changing. It is with the subset of data that you've got, but that's not what's going on across the board.
So that's a great point, and maybe that's a consideration, you know, given that we're aware that this particular region has also had a good long history of people informing them and growing their knowledge around soil acidity and application and lime and so forth. But yeah, maybe look at the bigger context. I had another, thanks, Steve. Another question with the app that you're doing. Like, I really like the model scenarios. Have you considered, or are you using those modelled scenarios on sites that were maybe sampled back in 2005 or whenever, and then sampled again in 2021, and using them as sort of a validation of the actual site change, you know, rather than just look at the model predictive?
We haven't looked at specifically the ones done in 2005 that I know of.
Yeah.
But that's why we're working with the agronomist. Because you've got the 5 to 10 year history.
Yeah.
We will go and look at 2012 and how it compares to now.
Because that would be really neat.
We'd hope very much that it will reflect what goes on, because it's built from hundreds and hundreds of trial years of experiments with different rates of lime over different lengths of time. You saw how young I looked when we started. So we'd hope that it does, you know, what it's reflecting and what it's modelled on is what will reflect. So it's a good thing to test, actually.
And I would like to go back to your comment, Steve, because I think it's like I can only comment on the data that I have. And obviously, I felt like that when we're putting the tender out to people to go and do this, is that it's always the proactive people doing this stuff.
Yeah.
Chris, how different was it when you were doing the 2005 to 2012 study?
I think, again, one of the reasons we're doing the soil test or precision soil test is that we are replicating what those earlier studies that led into the report card were. The main outcome out of that process was to actually encourage and rapidly increase the amount of people that were actually looking at 10 to 20 and 20 to 30, those subsoil layers. But I guess, yeah, you are picking people instead. It's a really valid comment. If anybody has any ideas how we look and see what the recalcitrant people, people that have maybe not even recalcitrants, but maybe they're people with, you know, different priorities, and just see where those are going. But really, we can only go on what we're getting at. I think, you know, looked at the results, you looked at them with Alice. It's a real improvement. It's probably not quite as much as we hoped for back in 2008, but bearing in mind, I think it is still actually a real improvement that we're seeing. And when we get, or as we get this data out and extended more and more, we hope that that next cohort of people will get up and see it. You know, some of them
I don't
follow.
disagree that it's an improvement. It's clear that the improvement is going on, but by default, by looking at the average of what you're seeing, those that have done well. I mean, you talk about those line rates of 2 tonne every 10 years. You know, basically throwaway yields are maybe 3 tonne, and I always work on 10% of the wheat yield as being the replacement required per annum. So if you've had 15 years and grown somewhere between 10 and 15 tonne of wheat, your 2 tonne upfront is only going to hold ground, which is what your modelling is showing. So to actually get the improvement that you need and get the movement down, that 2 is not really in the game. It's got to be 2 and 2 and probably another 2 to get that process to happen over scale. And if you have 10% of farmers doing it, following, you know, best practice, if you like, and they have a big improvement, but another 20% are doing, you know, a portion of best practice, and then another portion of doing none of best practice, then overall your impact, I guess, is just less than you would like it to be, which I think is what you're showing.
I've got a sort of practical question.
Sorry, I wasn't looking that way.
From a farmer's perspective, with the trend to no-till or minimum till agriculture, is there a conflict with the obvious benefits from incorporating through tilling?
Well, that's, yeah, we don't, when we're talking about strategic tillage, it's a one-off pass where we try and only do, so essentially a farm will be hopefully controlled traffic. So they'll just be driving on these tram lines, and then they'll have issues because we've been no-till for so long, such as like non-wetting, but then also other issues such as acidity or compaction. And we say, okay, we don't want to till the soil every year, but we need to do something because we've got non-wetting and we need to get possibly the line down. And we also need to probably get rid of compaction. So 1 year we're going to go through and possibly either, deep rip and have topsoil slotting plates so that the topsoil goes down, so we have lime mixing down, or a one-way plough, or, they're building so many different machines to do just a tiny different thing in a different area. So yeah, it's that concept of we don't want to till the soil, but we know we need to do this to overcome other constraints. And then we go back to doing no-till.
And I have a second question for mine.
Yes.
Have you seen enough change in soil acidity to be able to reflect on how that's changed farmer fertiliser practices? I mean, are they now able to mine phosphorus from those deeper layers? Are we at that point yet? And then thus reduce phosphate use?
I would say I don't want to comment on all farmers, but I don't think we've reduced our fertiliser use. But I'd say our fertiliser efficiency has got better.
I think I'd agree with that. I mean, it's difficult to measure, as you know, but I would say that is, we're growing bigger crops with the same or reduced amount of rainfall. So the efficiency is definitely improving where people are getting their soil condition, and from a range of fixing a range of multiple constraints. But definitely, big improvements. I mean, if you go to the extreme, which was the slide of some of the work that they're doing with the re-engineering and really changing the soil profile, it's not uncommon to see a doubling of yield there with, between the untreated and the treated profiles.
And are you seeing levels of P in the subsurface samples, the 20 to 30, 30 to 40 that if it were brought to the surface, that would be a source of P? Or is there a P profile at all?
In terms of phosphorus, I know that lots of people work kind of on a replacement strategy of what they took off the year before. They want to put that back on, maybe a little bit extra, depending on their PBIs. I don't know. I don't really know.
Limited number of people test phosphorus to depth.
Yeah.
Very small subset.
So in this sampling, it was only acidity tested there, not.
No, some of the growers, so Precision Soil Tech provides the sampling and also pH. So they'll provide that, and then growers, they'll say, if you want to sample all the rest of the nutrients, you can send it to a lab and they'll freight it to the lab. So the growers pay for that sampling pH, and then it'll go to another lab and they'll get a suite of data. So some of our results have more information and some are just pH.
So I have got an online question that kind of follows along from that, and maybe just is trying to claim a future research question, but it's, have you looked at soil phosphatase activities, phosphorus availabilities and correlations with liming? So we've had a little bit of discussion about that already. So I guess that's the, is there something in the data set that you could look at that might consider how you address those questions, or maybe it's a future research question?
Yeah, no, and that's I guess a good thing about doing a presentation midway through a project is that get people to ask you to do other things with the data. We haven't done that yet. We do have some other, some of our soil tests do have more information about them, but yeah, I don't know that many would have much information to depth.
Yep.
So.
Yeah, not specifically. I mean, the main thing, the argument with this project is, do you look at a few samples in a great amount of detail, or do you do it the other way, following on from the report card, where you look at a huge number in a much lesser detail to get more of an overall picture? the hope is that we will pick up and we can target some people that haven't been, or we can separate out the people that we end up sampling across this, maybe get 150 farms, and that we will be able to look at some that haven't got a history of soil testing, join the project, and we can maybe pull them as a cohort apart from people who got the earlier information and how the different groups adopting or behaving. So,
I have a question from me. You mentioned environmental impact at the beginning, and just thinking about your project partners. Is there a linkage, or are you building a linkage between what's happening in the soils and with pH to something along the lines of water quality in riverways that are close by, or is there any?
No, so the project's on farm soil acidity.
Yep.
So specifically looking at how we manage soil acidity on farm and nutrient management. So that's kind of the brief of our project.
Yeah.
Obviously, that's the reason we're funding it, though, is because it's a positive way to be engaged and to make sure that everything is working well. But no, we're not testing any waterways.
Okay.
But we do sample the Avon River and tributaries every month.
Okay.
But as Chris points out, you have to get practice change at scale before you get any kind of measurement difference.
Yep.
And here we're talking about a number of steps. You've got to get practice change at scale with liming to improve pH. Then comes the fertiliser nutrient.
Yep.
Then comes the measurable effect in the waterway. So
long-term game.
As I tell our minister, it's going to take a generation
Yep.
to make a difference. Generation of sustained investment.
Yep. Great. Thank you.
I
Steve?
just want to comment about Malcolm's question about phosphorus and whether there's a change. I think from what I've looked at, within the urban catchment, I think it's not really widespread, but in the northern ag region, there is a significant change. So people have definitely jumped on and limed more because lime is much closer as a general statement in the northern ag zone. And they have gone and put much higher rates and got pH change to depth. And as a result, they are certainly the top 20% of growers have definitely dropped phosphorus application rates significantly because they've actually achieved that process. I think it's just slower to happen in the Avon River Basin where you've got further the lime to be transported. You've got lower spring rainfall as a general statement compared to closer to the coast because the agricultural area triangulates across our coast. So the process is underway. I would think it might be a 5% of growers are perhaps tweaking phosphorus in this zone, but that's significantly less than in the north.
It's great insight.
Yeah, I just want the other opportunity I see is, as you know, the Commonwealth is investing, encouraging farmers to do soil testing, and the Commonwealth, in their own peculiar way, say, well, do lots of soil tests and give us lots of data without articulating what actual sort of data and what it may get used for, and they're coming out now with methodology. And I think you guys are involved with that national program, aren't you?
We're not involved in delivering the new service that they want to have on farm testing at this point, primarily because they've got some criteria that I don't believe in, so I'm going to blame.
So do you see opportunities though in a national focus if it were refocused?
If it has some
measuring the right
thinking applied to it appropriately, that would be a good idea, but that seems to lack.
That's right, and just offering farmers 10 grand for soil test, whatever you want to soil test, but not some particularly useful investment, but we're all trying to influence that. So maybe an opportunity to get wider soil testing and more extension of this kind of the research that you found, because you've got the story to tell.
And I think it's really like working with the agronomist is really important. Maybe it's only one agronomist and one thing, but it actually gives me the ability to see change. And I don't like I know Soil Tech has this, they've spent a lot of time sitting there looking after their data set, and so they've been able to see change, but you can't just come in and just look at a one-off data set unless you're resampling. So yeah, I don't know.
Indeed, yes.
I just had a quick one. I just
Yeah.
wondered whether or not the extension activities you've got planned would be a good opportunity for like a cheeky survey or trying to, I guess, capture some of the, not just the best practice guys, but getting more of an idea of maybe what's going on with liming. Like,
Oh yeah. So I mean, a lot of the people that are involved in the project are people that I've done through other work. So what we're going to be doing is trying to piggyback on their grower group kind of days. So come to a grower group meeting and ask them. There's a mixed bag of people, but
yeah, I think maybe you capture more viewpoints than just kind of, I guess, the people that are really keen to be sampled. You might get the kind of more hesitant people who can figure out what the average person's doing.
But I think that's the good thing about the grower groups, is it brings everyone together, and you get kind of a very different, 20, 30 farming businesses, close proximity. They've had different succession plans and different transitions from buying farms. So there might not be bad, there might be really proactive farmers, but they just bought that farm down the road 2 years ago and it's been run down. So yeah, I mean, I could see that in the data set because I knew some of the farmers. So it's like, oh, I know what that is. So yeah, I mean,
it might go some of the way to answering some of those questions around how representative it is, I guess, if you can actually just like, it's really sort of like who's doing what, put your hand up in, applied in the last decade or whatever.
Yeah.
Anyway, thanks.
Any other last questions? No. So Alice, I love the slide you finished on. Because for those of you that aren't aware, if you haven't seen them, there are the soil quality ebooks. This one is the one on soil acidity that Chris and others have been involved with. So they're free to download, Apple platforms. Take the opportunity to read some more around the subject that Alice has talked today. But there's also several other books. So we've got 3 more to come. Hopefully Sodic and Alkaline Soils will be launched at Darren Field Day. Cross fingers. But I'd like for everybody to thank Alice for joining us today and for giving us her talk around her work with the growers in the industry, importantly on soil acidity.